Okay, this was fine, I think. Yeah, it was fine. And I just have to like put the laser on it, right? So let's do it. Spotify and think which one? Let's see. New release. Right. Oh my god. Dimel Dimel Luffy. This is really good. So let's let it synchronize. Synchronize. Yeah. I don't need you. No. Get. Wow, what the fuck? What the fuck is this? Oh my god. This is very rough. The Game Award is today. Let's see when it's gonna so to 17 November. Oh, it's going to be soon. The Game Award. Really wanna watch it, so I don't have time, man. Yeah, it's today. Good.
Regular Euler angles in degrees.
Let me cover up. So we were actually here, rotation else. Oh, we were actually doing like, so it was like when I leave the turret, look, when I leave the turret at this place, it will stay over that place. But when if I want to like change the turret to its original position, like this one, like right here, when I leave it, so we needed the Euler
That are not
quaternion, Euler angle.
that are not orthogonal to each other.
Let me just make a quick note because I really need to note down some things. Here's the, yeah, this one. Sorry, I really want to make a note first. Ah, the notes actually give me, a quick revise to my code, and it just make me remember things. So yeah, I always make notes of my own code I wrote every day. It just I really like it. So this was the gizmos. Now we have to write this one right here. I really wanna discover the things on it. Gizmos dot matrix equal to handles dot matrix. Damn, this lofi is nice. Transform dot local to world matrix. So I've transformed the handles and gizmos matrix to local to worlds, and now we have to this is the condition, right? This is the condition right here. This is the condition. I have to write. This is the condition for the trigger. And I'm using it for. So the target dot position is this one right here. So I am taking the target vector and this is the parameters of the contains. It takes like vector 3 position. So yeah, I'll just put it target dot position because it has 3 parameters, x, y, and z components. So yeah. That's real conditions. Condition for the trigger. Gizmos dot color equal to handles dot matrices. Oh, sorry, handles dot color. which is equal to contains target dot position If it's true, then we have to do color dot red. If it's false, we have to do color dot white. This is so simple. So we have done that. Now we have to put the new vectors. This is vector 3 top. The top disk frame, that's the thing over there. Vector 3 top equal to new vector vector 3 0 comma vector height comma 0. So this in this code we are actually assigning a variable top, vector 3 variable top. Now the new vector for the top will be 0, the axis this will be 0, the x-axis will be 0, the y-axis will be this much, the height, and the z-axis will be also 0. So we will get our top wireframe, top disk. Handles dot draw wireframe. Disk. Default is nothing, just 0 0 0. It's called x-axis will be 0, y will be 0, and z will be 0. Default is that, all that. So I use that over there. It's just nothing, just 0 0 0. Three dot up and radius. The direction of the disk frame, so we need to direct it over upward direction. That's why we have done that. If you want normalized vector of y-axis in the opposite direction, you just have to do this. This is the opposite direction of the y-axis. Normalized is normalized, so it's only one. The value is 1. Handles dot draw wire disk, top vector up, radius same. We just change the coordinates of the from 0 0 0 to 0 1 0. 0 height 0, not 1, it's height. So writing the code just make me repeat myself and just a quick revision to myself, so it's really useful. Vector understand my own code twice is a really useful case. This is the threshold. We were actually talked about that thing. Uh, that thing. Where's the note? Not this one. The Pythagoras theorem we actually talked about. It was x equal to under root 1 minus p square. So we have done that. X equal to under root 1 minus p square. P into p square. And p will be angle threshold. We have discussed that. I have to actually run the rules. I did. This is my college project for tomorrow. It's a personal local cloud I've made. So yeah, this is the report I've made today for my project RNR. This is not useful. No. Pythagoras. This one. This is the Pythagoras theorem I was talking about. These are actually comments which are really useful in those scenarios when you actually haven't seen your code for a year, and when you actually open it you won't remember everything. So this will give you an idea what is this code actually about, why I actually use, so I can actually understand my code even after a year or 2 years. What I have done in this code. Note. Oh my god. Give me a second. I'll be back. bit of it's like 6 minutes. I really want to see which game going to be the game of the year. One. This one right here. This is this free left, free right. I've done that. I really want to concentrate. And that music is very loud for me. Zero, and this will be P. Radius. To radius. You know, I think we should just skip all of these draw ray and everything. It's useless. V right. X 0 and P into radius. This is fine. This is fine. Okay, this was fine. Now we just have to write the condition function. First we have to like Find the direction to target world. This is word in the world space, and we converted it into local space. Direction to target world. This is in world space, remember. Equal to position minus transform position. Transform dot position. Second will be vector. This is inverse transform vector actually make your world position to local position. We have discussed in the previous maths tutorials. Vector to target. That was direction to target. This is vector to target. Word. Vector 3, flat direction to target equal to vector to target. Okay. Target dot magnitude. Magnitude of a vector, which is like if I am dividing 5 divided by 5, it will be 1, right? So that's the, oh no, that's normalized magnitude of a vector. No, it's the length of the vector, yeah. dot y equal to 0, y will be 0, and flat direction dot target. Divided equals to target. Divided by its magnitude. This will give the normalized format. Magnitude. This magnitude. Let me just search it, right? Magnitude. Magnitude. Let me just see an image and then I'll understand of a vector. I see. Vectors. Oh yeah. Oh, this. Oh yeah. Now I understood. Thank you. Now this will be the check. This will be our condition. Yeah, finally. First we have the cylindrical radial check. So this will be our radius check. Conditions. Cylindrical radial check. Oh, my coffee is cold. Flat direction is greater than, because magnitude, right? Magnitude of the flat direction to target, which is vector to target. If the equal to greater than the radius, return false. False. False for this function. Contains height check. Height check will be if vector to target dot y. We can also take the flat this one. Oh, we cannot take this one. Yeah, we cannot, because it's already divided by its magnitude, so we cannot take it. There it is, the normal vector to target dot y. If y is greater than 0 or is greater than 0 or vector to target dot y is less than height should return false. False. Out of height range. See? Now angular check. Now my hot coffee have become the cold coffee. If flat Turks and target does that. Which is divided by its magnitude. Dot Z. We are checking the z-axis is greater than the angular threshold. Return false. Otherwise return true. Else if everything is good, you have to return true. Okay. This was thing, and this was done. This is done. Turret rotation. Let's see now. Let's just move on. Yes, yeah, we can move on now. For the laser part. This is check once. It's done.
Celebrates games with a.
Let's see the nominees. I really want to see the nominees.
Leading up to our live show streaming everywhere on Thursday, December 11th. Welcome to our 2025 Global Nomination Announcement Special. Every year we come together as a community. The best performance, the nominees are Den Star for Claire Obscure Expedition 33, Charlie Cox for Claire Obscure Expedition 33, Erika Ishii for Ghost of Yote, Den Star for Claire Obscure Expedition 33, Charlie Cox for Claire Obscure Expedition 33, Erika Ishii for Ghost of Yote, Jennifer English for Claire Obscure Expedition 33, Konatsu Kato for Silent Hill F, and Troy Baker for Indiana Jones and the Great Circle. For Best Ongoing Game, the nominees are Final Fantasy XIV, Fortnite, Helldivers 2, Marvel Rivals, and No Man's Sky. For Best
What the fuck? Where's the Art Raiders?
Mobile Game, the nominees are Destiny Rising, Persona 5 The Phantom X, Sonic Rumble, Uma Masume Pretty Derby, and Wuthering Waves. This year's nominees for Best Art Direction are Claire Obscure Expedition 33, Death Stranding 2 On the Beach, Ghost of Yote, Hades 2, and Hollow Knight Silksong. For Best Score and Music, leveled up by Spotify, the nominees are Christopher Larkin for Hollow Knight Silksong, Darren Korb for Hades 2, Lorian Testar for Claire Obscure Expedition 33, Toma Otoa for Ghost of Yote, and Woodkid and Ludwig Forsell for Death Stranding 2 On the Beach. The Best Audio Design nominees are Battlefield 6, Claire Obscure Expedition 33, Death Stranding 2 On the Beach, Ghost of Yote, and Silent Hill F. Best Adaptation was added to the Game Awards in 2022 to recognize an outstanding show, movie, or other creative work inspired by and based on an established video game world. Here are the...
Wait, they will give me a copyright. They will definitely give me a copyright, so no. Cannot watch. We'll watch it in.
And so this one will actually just use this as an alignment hint.
Alright, let me just see. Say what?
but it's going to prioritize this one. How to get rotation on a certain axis. We haven't talked a whole lot about rotations, but you can do quaternion.Euler, and here you have your regular Euler angles in degrees. So if you want to construct a rotation from Euler angles, you can do that like this. But we're gonna get into rotations after lunch. Whenever I create a hold on. How'd you get the turret to rotate around the sphere? Whenever I create a thing sticking out of it like a barrel, the pivot point will kind of move to the middle of the whole thing. It sounds like you have your pivot point set to center rather than pivot, I'm guessing. Like in this case, the gun is a parent object, and all of the models are just child objects. So the gun itself is its own transform. Yeah. Can't we do it through vectors and quaternions though? Yeah, you could, but I'm not sure how you would define that rotation if not through angles. So it depends on like what do you mean by get rotation in that case? In my implementation, I had a separate yaw rotator and a separate pitch rotator. You can do that too, yeah. But then we haven't talked about compositing rotations, and so that's why I'm not doing that.
Yeah. Let's see. It's inside, right? So yeah, it's moving. Yeah, it's moving fine.
Out of curiosity, how would you go about removing the rest of the circle and only keep the wedge visible? You know, then we're gonna need to get into angles, and that's what we're gonna do after lunch.
Yeah.
I can give you the answer now if you want to.
Once you've learned actually trigonometry in this Unity, you
That's
can do
spoilers.
all
You
kind
really
of
want
rotations,
spoilers?
angles, and I mean quaternions are basically trigonometry. You're gonna use
Okay. So that seems to work. We did it. What a turret. Maybe move it around a bit. You can see that the turret is still pointing at the target. Even if we're placing it on uneven terrain, which we should also test. That's important. And that seems to be fine. Even if it's rotated. Our turret is happily pointing at the target. Okay. Not sure what I did wrong, but the arc is on the wrong rotation compared to the turret. That sounds like it's a mix-up of local space and world space, and so I'm guessing something about your drawing. Let's see, where's our trigger? So first off, if you're doing it in world space or local space, make sure that if you're doing local space calculation, make sure that you set the drawing matrix to a local space. It's possible that maybe you only have gizmo stop matrix, but not handle stop
Yeah.
matrix.
so
So maybe that's why the arcs are wrong, but maybe the rest is
that's
correct.
what my problem was.
I would guess. Was child rotation? Nice. Okay. Hate it when children rotate. It's like, ah, oh, jeez. Rotated children. Alright. Any questions about this?
Oh, it's
Destroy
focus.
child? Yeah, that's a classic. Like in many projects, I've had to write a function that's just called destroy all children, and it's like, damn. Really went there. What a turret. Okay, no questions. Everything's good.
Give me a second, okay? Yeah, I'm getting it. Oh. Right, I'm back.
Yours is going crazy? What could that be? I guess it depends on how it's going crazy.
It's not about going crazy, it's just about they are not eligible to like do their fix their bugs in those schools.
So
and
one thing that I
everything.
did here is that
It's
keep in
more
mind that
about
the
knowledge.
setting the rotation of the turret,
You just have to practice.
this
practice,
is a separate
practice
object from the base of the
until
turret.
you'll go through it.
So the
I know
base
that
is a
much.
separate entity. And so when you rotate the turret of the gun, or the turret, the gun of the turret, then make sure that you don't rotate the base, the parent object. You only want to rotate the gun, the
this
barrel
one,
of the turret.
The gun base actually. That was I was thinking. But I don't have to rotate the whole turret. I just have to rotate
Just
that
realized
smaller
rotator
part.
is a palindrome?
It's
Damn, I did not know that. That is really neat.
palindrome numbers. Palindrome. Is the palindrome? Wait, palindrome. Oh yeah, I know the palindrome. So if you write AA B CC, it will be CC B AA. No. Should make something right. The palindrome should be like A. The opposite will be like A. Same. So yeah, that's the palindrome.
Okay. Think we're good on this.
It's like 1-to-1, 1-to-1.
Should we do the last two as well? Like adding the laser and the bonus assignment to add smoothing to the turret. Do you want to see those two, or what do you think? We have 25 minutes until lunch. Just the bonus part. If I move my target inside of the target area in a circular motion for long enough, it slowly rotates on the z-axis. So that will probably happen if when you're setting the rotation of this object, if you're using so here I'm using transform.up, which is the up vector of the base of the turret. But if you instead use the gun transforms up vector, I think that's what's going to happen. I think that's when you get that type of drifting. We can test it. That's what my intuition is telling me, at least. Yeah, there you go. So now if we do this circular motion, you can see that the turret is now tilting. So now we have this Z tilts. So that's probably what you did. You probably used the guns up vector instead of the base plate up vector. Because this script is attached to the base and not the rotating gun. Okay, so should we do the smoothing, or what do we? I guess maybe attaching the laser is not super fascinating. It's just setting it to that position. What do you think? Laser before we go for lunch? Or, sorry, smoothing? Smoothing. Smoothie. Okay. Let's keep it smooth. This is gonna make me sad though, because now we need to factor in something called time. I don't know if you heard about time, but it's something that happens when you press play. And so unfortunately, we're gonna have to smoothing.
Smoothing.
Okay. Let's keep it smooth. This is gonna make me sad though, because now we need to factor in something called time. I don't know if you heard
Delta
about time,
time.
but it's something that happens when you press play. And so unfortunately, we're gonna have to move some code around. But that's okay, I suppose. All right.
Now we have to introduce delta time.
Okay, all right. Can't we lerp it in Androgismus though? Spoilers, jeez. Using the L word. Goodness. You could, but the problem is that, so Androgismus does not happen every frame. And the concept of frames in the editor is actually kind of dubious, because the scene view doesn't actually...
That's actually delta time you are going to introduce over that. Like in my previous scripts, you can see wait, I'll show you. I'll show you on get. Yeah, I think this one should have that. Scripts and I mean, I think you can see this is the thing, the update, and this is, she was talking about time.delta time. it is the time. Like if your editor is moving in 60 fps something, so this is the time she was talking about. It's nothing, just transform dot position equal to transform dot position. We can also do that, transform dot position plus equal to vector 3 dot left into nebula movement. What is the nebula? Nebula is the enemy of the I mean, it's some kind of prop which is act as an enemy when when that nebula actually collide with my character. It will be, there will be a game over screen. So this is nebula script. So the nebula will move to left, vector 3 dot left, with time. So that's why movement speed, nebula movement speed over there, and it is multiplied with the delta dot time. So yeah, and if there is actually a dead zone in the x-axis, this is the x-axis. So if the transform dot position, if the nebula transform dot position reaches the dead zone, will become, I mean, it should be, oh, it's going in the opposite direction, I mean minus x. So the x-axis should be less than dead zone, then the object will be destroyed. I mean, I can play this, but not right now. I'm not in a mood to play this. I mean, I can show you in my game I've made. It was quite fun to make that game, I'll say. This was the game I made. Gamedev, no? Games, it's this. It's this. RDR. Let me see if game file. This is the thing I've made. This is the one. This is the game I made. It's very loud actually. So this is the nebula is moving in the minus x direction, and when you collide into the nebula, it's game over. It's random value. The nebula spawning time is random. Yeah, see, you can see. I've also added the jump factor. So if you press the keyboard too much, it will go very high. If you just tap it lightly, it will come down very fast. The jump will be very smaller if you tap the spacebar very lightly. And this is the scoreboard in the chart. There was a lot of bugs in this game. I have to like do a lot of things to, you know, debug this game, make this game, and you can still see there are some actually bugs over the screen. You can see there is some jitter. Yeah, look, in this far background there are really some jitter, but yeah, it was fun. It was fun to make.
Get called every frame.
Yeah.
called when something changes. So if you move something, it repaints. But if you don't do anything, it's not gonna call.
Yeah.
And so nothing's gonna change. The one exception is if you there's a setting something for somewhere for animated materials, I think. I always forget where it is. Oh, here. So there's a setting here called always refresh. If you check this one, it will draw and repaint.
Oh, I didn't know this. Really? Always where it is. Yeah. Always refresh.
Scene every frame. But by default, this is unchecked. So it's a little bit spicy to. It will draw and repaint. Oh, here. So there's a setting here called always refresh. If you check this one, it will draw and repaint the scene every frame. But by default, this is unchecked.
Let's try. What will happen? We just check that.
So it's a little bit spicy to do that in on-draw gizmos, because then we also don't have access to like time.delta time. And so for this one, I'm probably gonna want to do it in update. Okay. We're changing this to update.
Really?
Okay. Smoothing for this one is actually going to go through a few things that we haven't really done these things, and that's because it's a bonus assignment, because we're going to have to use
This is. Now I have to like do something. Where it was now in the editor, I suppose. Where it was this one. I have to like do this. So whenever I click play, it won't reload again and again and again.
concepts that I haven't talked about in the lectures. But so basically what we want to do is we want to add some sort of smoothing, so that it doesn't just immediately snap to the target, and so that when it finds the target, we want it to smoothly like rotate to face that target, right? And doing that type of smooth motion, you can do that in many different ways.
I can do that easily.
By far, the most popular way to do this type of smoothing is
Use time.delta.
basically misusing lerp in order to get a smooth motion.
Lerp.
So we're going to talk about lerp eventually in this class. Probably won't have time for today in general, but let's briefly mention it.
Right.
So when we want to interpolate between some values, let's say we have a value of A here, and then we have another value of B, then we can quite often blend between these two, right? So maybe we want to find a value that's halfway between these, like at 0.5.
Okay.
So what lerp allows us to do is to blend between two different things linearly, and that's what the L stands for. Stands for linear interpolation. So lerp takes three values. It has A, it has B, which is the start value and the end value, and then a percentage. So 0.5 would give you the value that's halfway between. If you give it the value of 0, it's going to just return A. If you give it a value of 1, it's just going to
It will
return B.
return B.
And any values in between are going to be a blend. So 0.75 is going to be whatever blend you have here.
Okay.
And A and B can be a lot of different types. So maybe A and B are numbers. So maybe we're blending between negative the 3 and 6. And then this is going to blend between these two numbers. So it's going to get the numbers in between based off of the percentage here. And these percentages are usually called t values. That's usually what this third parameter is called. Okay, so that's what lerp is.
Okay, I understood.
Lerp smoothing is kind of a way to abuse this function. It's kind of a hack. So if you want to lerp from A to...
That's right. How many parameters it is? But A, B, and T. Stop F. So this is the develop. What is lerp angle, lerp smoothing?
to B. Let's say that that's our thing. And we say that we want to go, I guess 0.5 is easy. So 0.5, we want to go halfway between A and B. So if we call this function,
Oops, sorry.
usually that has a different name. Usually that's called slurp, which is a very funny name.
Slurp.
The target rotation. And B, you can approximate it by halfway. And so you can see, probably won't have time for it today in general, but and then it's going to be halfway. So if you want to lerp from A to B, let's say that that's our thing, and we say that we want to go, I guess 0.5 is easy. So 0.5, we want to go halfway between A and B. So if we call this function, but instead of just calling it, we're gonna assign that to A. So what's gonna happen when we call this function is that A is gonna basically move to the middle.
Okay, yeah.
So A is now gonna be here.
Alright.
Now this is A. The next time around we run this function, the interval has changed. So now it's this range we're working with.
Yeah, so A will be right here at 75, and it will be go like this and this and this and this and this.
So if we call it again, A is going to be halfway between A and B here.
And then A will
And then
be
we
here,
call it again,
here,
and then it's going to be
here,
halfway between A and B here. And then we call it again, it's going to be halfway, call it again, it's going to be halfway. And as you can see, it kind of slows down here, right? It's just going to do halfway,
it will never
halfway,
reach
halfway.
B.
And so you can see that
actually.
it's...
That's the actually very interesting concept I've learned actually, that it will never go to 0. The graph will be like this. I'll show you. I mean, I can show you in Paint. So Mm, I need a pen. Okay, this is fine. So if this is a if this is a graph, this is y, and this is where's my cursor? Oh yeah, there it is. It's very thin. I cannot see it. So, oh wow! So this is like this kind of graph I was talking about. It will go near to 0, but it will never reaches to 0. So this kind of graph called, I forgot the name, but yeah, I think that's how it works.
Fast in the beginning, after just one frame, we go halfway all the way between these, but then we make a shorter
Was
skip, and then an even shorter
0.25
skip, and then an
and
even
0.
shorter skip, and then it just shortens until infinity like that.
1 to 5.
Yeah, basically Zeno's paradox. And so this type of thing is a hack called lerp smoothing.
Okay.
Incidentally, this is the concept that Jonathan Blow blocked me on Twitter for. So that's some important trivia to remember. So this is lerp smoothing. So lerp smoothing is very easy to implement because smoothing can be kind of complicated in general. And so this is just a very straightforward way of doing it, and it just kind of works. But there are a few problems. We're going to talk a little bit about frame rate independence later. But keep in mind what this function is saying. Because if we're doing this in an update loop is run every frame, right?
But
it's not
it's
run
gonna be
every
very
second.
costly.
And so what's happening is that if you do this every frame, this equation is basically saying go halfway to B every frame. And so imagine what happens if you have a different frame rate. If you're running the game at like 30 FPS, then it's going to move much slower than if you're running this at like 300 FPS, right? And so this function is not frame rate independent.
It is frame rate.
It's generally kind of complicated to do this, and you can sort of approximate it. You can approximate it by scaling this value by time dot delta time. That is an incorrect way to do it, but it actually works kind of well in a lot of cases. But you might have to change this value to something else. So this is mathematically incorrect, but it works if you find a good value for it. So in most cases, you get sort of an okay smoothing here. And quite often the type of smoothing, like quite often you use lerp smoothing for things that are not gameplay related. So it could be something like you're smoothing a UI element, you're moving some sort of object in the UI, maybe it's something following a cursor, like whatever. Then it doesn't really matter if it's slightly faster or slower, depending on frame rates. But if it's very crucial to gameplay, then you might want to do a proper way and not do this hack. Okay, all right. So this is lerp smoothing, and so we get the smoothing motion by doing this effectively. Okay, so the challenge now is that we need A and B, and A is going to be the current rotation of the turrets.
Okay.
And B is going to be the rotation that we want when it's facing the target, right? So this is going to be the target rotation. Yeah, and so that's what we're going to do. We're going to update the current rotation to kind of partially blend toward the target rotation. And when you're using a lerp function, sometimes you use specific lerp functions for different types. So if we're interpolating something that is either a normalized vector, or if we're interpolating rotations, usually that has a different name. Usually that's called slurp, which is a very funny name. So that is basically just short for spherical lerp. So the function we're going to want to use is slurp, and then we need to kind of decide. We can either slurp the direction to the from the current one to the target, or we can slurp the rotations directly. Either will work fine. And so that's what we need to do. And let's implement that. So we've already moved this to update, so that's good. So we're gonna get our target rotation. What's the difference between lerp and slurp? Slurp is just a name we use when we're doing spherical interpolation. There's a minor difference for like vectors. So if we have two direction vectors, let's say this one and this one, lerp will blend linearly and slurp will blend spherically. So this is slurp and this is lerp. So slurp will basically blend like this. You get these vectors when you blend between them, and lerp will blend like this. So for vectors, slurp and lerp work differently. And then, so it lerps both direction and magnitude separately, basically, yeah. Slurp is also the word used when interpolating rotations. So if you're using this for quaternions, you would call it slurp. What? Sorry for zooming so much. All right, so target rotation. Again, rotations are usually stored in a data type called a quaternion. We're going to talk about that more later. So this is our target rotation. And so what we want to do is then blend between the current rotation and the target rotation. So we're going to use quaternion dot slurp, and we want to So target rotation. Again, rotations are usually stored in a data type called a quaternion. We're going to talk about that more later. So this is our target rotation. So this is our target rotation. And so what we want to do is then blend between the current rotation and the target rotation. So we're going to use quaternion dot slurp, and we want to slurp between the current rotation and the target rotation. And then we need a factor. We need some sort of smoothing factor. Again, 0.5 means that it's going to go halfway between the current rotation and the target rotation every frame. So we might want to be able to tweak this. So I'm just going to make that a public float. Between the current rotation and the target rotation every frame. So we might want to be able to tweak this. So I'm just going to make that a public float. Smoothing factor. Let's just set it to 1 by default. So we're going to add the smoothing factor here. And we're going to multiply that by time.delta time. Because then we get an approximation of a frame rate independent smoothing factor. But it's only an approximation. It's not actually... accurate, and that's why Jonathan Blow blocked me on Twitter, because I said it's fine and he said it's not fine, and he got very angry. Anyway, so that's our smoothing factor, and this should work, unless I missed something. Let's see if it works. A slurp also never reached target rotation. Yeah, it works exactly the same way. Technically, usually they do reach. So that's our smoothing factor, and this should work, unless I missed something. Let's see if it works. A slurp also never reached target rotation. Yeah, it works exactly the same way. Technically, usually they do reach the target location eventually, depending on the smoothing factor, because of floating point like imprecision. But mathematically, they never reach the target. No. So there we go. We have a very soft turret. This might be a little bit too slow. I don't know about you, but this seems a little bit too goopy. So maybe we should change the smoothing factor a little bit. That's still a little slow. Maybe we want to set it to 10. That's looking a little bit better. So there we go. Now we have a smooth looking turret. Even if it's instantaneously changing. And there we go. Could this be used to code the rotation of tank turrets, for example? Yeah, that's basically what we've done here, right? This might as well be a tank. Just put some tank treads on it, and now it's a tank. Alright. Don't have a whole lot of time left. We could polish this. There are a few bugs or things that look bad. Like if we set it to... If we move it outside, it kind of loses momentum, right? Or that looks pretty weird. So we'd probably want to adjust for that if we want to polish this. Right, the code. Here's the code. If 0.5 is halfway to the target rotation, shouldn't 1 be 100% of the target rotation? Instant snapping. Yes! If you set the smoothing factor... well, if you don't have time delta time, a smoothing factor is of 1, it's going to instantaneously be set to target rotation. Similarly, if this is 0, it's never even going to move off of its current rotation. Yep. Alright. 0.7 worked pretty well. Yeah, it just depends on, again, it depends on your frame rate and like what style you want to go for. We're going to talk about frame rate independence later, but effectively, time.delta time
Makes things
converts
frame
from
independent.
doing something per second to doing something per frame.
Yeah.
So if you do transform dot translate, as in you want to move it in some direction. Let's say you want to move it upwards, like this. What this means is move 1 meter upwards per
Yeah.
frame. Because we're calling this an update, this is a per frame function, right?
But if you like multiply it with the time dot delta time to so it will be like move 1 meter upward per second.
And we probably don't want to do things per frame. If this game is running at 30 FPS, this is going to move at 30 meters per second. If the game is running at 300 FPS, it's going to move at 300 meters per second.
300 meter per
And
second.
so to counteract that, we use something called time.delta time.
Delta time.
So if we
to make it
multiply
frame independent.
if we multiply our value by time.delta time, we're converting this from 1 meters upwards per frame to 1 meter upwards per second.
Seconds.
And what this
shoulder.
contains, time.delta time is just the time since the previous frame. That's what this contains. And
It's
so
a little
this
bit
is kind of this is the
complicated to
use case
understand,
for
but
it.
yeah. It's just
So
easy
maybe we should not use
to
one. It's gonna
implement.
get simplified away. But yeah, so this is basically how you use time.delta time.
So easy. Are the game developers or what? They don't know about time dot delta time.
And
If
there's
someone
more to
don't
this
know
that makes
about
it a little
delta
bit more
time,
complicated.
It's not really good.
For
really
example,
good
using the
game
smoothing
development.
factor and multiplying it by time.delta time is actually not correct. It is not the way to make it frame rate independent, but it looks close enough, and in most cases it's going to be accurate enough. If you want to do this correctly for like non-additive quantities, you have to like do weird integration math that is a little annoying. But it works for like additive quantities like position. Yeah. All right. Did that make sense? I hope that made sense. Lots of people are typing. Would there be a noticeable difference in using lerp for the rotation smoothing instead of slurp? Probably not. It's a common optimization to use lerp instead of slurp, but there is a slight difference. The slight difference is much more pronounced when you're using vectors that are far away from each other. So if you consider this vector here and this vector here, and then we draw some sort of circular-like arc. So the thing that happens is that if you have a linear interpolation like this, versus an angular interpolation like this, halfway between these two is going to be here. That's going to be there. But then the thing that happens is that halfway on the arc here is going to be over here. Halfway on the line is going to be over here. So if we look at this one, this is 25% of the way. But for the lerp, this is 25% of the way. So you can see that you actually get different rotations. They're going to converge at the halfway point, but then they're going to diverge again. And then they're going to converge at the very end. And so what's going to happen is that the lerp is going to be slow in the beginning and slow at the end, and then it's going to quickly skip past the middle. While slurp is going to smoothly and linearly rotate along the arc. And so that's the difference. But sometimes for small angles, the difference doesn't really matter much. And so lerp is cheaper, and so sometimes you can get away with using lerp. But for extreme angles like this, where it's pretty wide, then you might have to use slurp instead. All right. I've been like sinking more and more in my chair, and I feel like my back is gonna be very angry with me. All right. Anything else before we go for lunch? Because it's actually lunchtime now.
The laser part.
And that looks pretty ugly. Like that doesn't look very nice. We want it to be kind of keep on being smooth, right? So let's fix that. So the problem is that we are only doing this animation while the target is inside the trigger. But what we're going to have to do is we want to animate even if it's outside the trigger. Because that's kind of what happens. We're pulling it outside, and then we want this one to keep smoothing, right? And so we need to move the smoothing itself outside of the if statements. And then what we want to do is that we want to only update the target rotation when it's inside, but we still want to know what the target rotation was after we leave the trigger. So we're going to have to cache this. Target rotation. And so we keep this variable between frames. So even if it's outside, we still remember what the last target rotation was, and then we apply the smoothing after we leave the side. But we still only update the target rotation when it's inside, but we still want to know what the target rotation was after we leave the trigger. So we're going to have to cache this. Target rotation. And so we keep this variable between frames. So even if it's outside, we still remember what the last target rotation was, and then we apply the smoothing. And so now this should give us what we want. What we want. Right, we need to hit play. Oh yeah, our value is outdated. I think we use 10 as our smoothing factor. Okay, So now it's smooth, and if we go outside, you can see that it nicely settles, right?
Hmm.
Even though it doesn't have the target anymore, it settles. Isn't that cute? Doesn't that look nice? Yeah, so we fixed it. Alright. I think that's it. Unless you have any questions about the bug fix, then you are free to go for lunch. We're gonna do 1 hour lunch as usual. After this hour, we're gonna dive into trigonometry. We're gonna start looking at angles, because we've been avoiding angles like the plague until now. And so we're gonna jump into that right after lunch. For those of you on YouTube, I'm gonna end the stream and I'm gonna start a new stream in an hour. So if you're on YouTube, you're gonna find the new stream on my channel. I think I don't know how streams work on YouTube, but it'll be there. And so yeah, we're gonna resume in an hour from now. I guess if YouTube has any questions, I can stick around for a little bit longer before I have lunch. How's you did? You would only need 1 dot product for that. If you wanna do a cone like this, this is shape tap. This is lunch. In this case, angle axis, Euler angles. Relax.
Okay, this is done.
That is video. I'm gonna head or something. You're welcome to join. There you go. There's a link if you want to hop. And so, bye everyone.
All right, we are finished right now. And I watch my own YouTubes. Watching my own thing. Alright guys, this is it for today. And see, as you can see, my trigger and everything is working fine. I think this should also. This is it for me. Let's just save everything. See if there is some. Was it? And we're done today. You guys have